All right, you guys ready? So the transformations and characteristics of rational functions, that's the practice assignment that we're turning in today. I'll come around in a little bit and get those. And then we had these notes. Okay. So how far did we get in the notes? I know I did the first part.
There's a bunch of examples.
Did I do this example? Did I do this example? Okay.
You didn't do Marco, and then you didn't do the Wicker against wind current, the first part.
Okay.
And then, yeah, the whole last sheet.
Okay. All right. So we have Marco can build a laptop twice as fast as Cliff. Working together, it takes them 5 hours. How long would it have taken Marco alone? Okay. So we have Marco. We have Cliff. Whenever they do stuff like this, it always messes me up, like with who gets like the X, who gets the 2X, you know? So what I like to do is I like to put a number in because that is common, that's like intuitive, it's like common sense, and then I erase it and then I put the X's in. Does that sound okay? All right, so let's come up with times that we can use and then we can like take those times out and like put our variables in. So someone come up with a time that you think it could take somebody to build a laptop. 7 hours. So I'm going to say Marco. Let's say Marco is 7 hours. If Marco's 7, then how long would Cliff be?
14.
Then Cliff would be 14. So I'd say 1 over 14 for Cliff. Are we comfortable with that? Because he'd be twice as fast.
Wait, is that a Marco that can build it
Twice as fast. So twice as fast. Yeah. We good? Does that make sense? Twice as fast? No. It's going to be a variable because it's twice as fast. But the numbers make more sense than the variables do. So now I'm going to go back. I'm going to put a variable in. So now I'm going to say, okay, this is X. Yeah. Because for some people, the variables are really easy. But a lot of students would say Marco's twice as fast, so he should get the 2X. But then they would get the answer wrong. They would have their answers backwards. So for me, it's easier to put the numbers in because numbers to me make sense. The variables to me are confusing. So I do the numbers first, and then I put the variable back in because then I go like, okay, now I know I've done it right. Does that make sense how we did that? So if Marco did it in 7 hours, then Cliff took twice as long because Marco was twice as fast. They did that on purpose, by the way. They phrased it like that to make sure that you were thinking through how you wrote your variables because most students, if they were rushing, would have done it backwards. Does that make sense? Okay. Working together, it's going to take them 5 hours. So what should our equation be?
1 over X plus 1 over 2X equals 5.
Equals
1 over 5.
There we go. It's okay, we got it. We just had to have a few prompts there. Okay.
It's a little typo.
Yeah, it was a typo. Okay, so our common denominator between x, 2x, and 5 is 10x. There we go. So we're going to take the whole thing. We're going to multiply it by 10x. Abby, hello. Abby, I'm going to have you... Would you like to come up here and join this group? Abby, they were real excited. That's actually someone's seat. She might be here from PCC, so I'm going to have you hop up here because this is nobody's seat, and then you won't feel awkward if she does come. Okay, so we're going to multiply by 10x because 10x is the least common denominator. Also do 10x, okay? So we had 2 times 5 times x, so 10x. Okay, so now what should we do? Yeah, we're going to multiply. 10x needs to multiply by each of those fractions. So we're going to have 1 over x times 10x, 1 over 2x times 10x, 1 over 5 times 10x. Just making sure that when we solve this equation, we're not going to have fractions in it. So what is our first term? 10. Okay. Second term, the x's cancel. 10 divided by 2 is 5. Okay. The x is going to stay, and then 10 divided by 5 is 2, so we get a 2x.
Why is it?
Okay, and then what do we have?
10 plus 15.
Yeah, 15 over 2, or we could say x equals 7.5 hours. So we were actually pretty close with our initial guess. Yeah. So Marco would take 7.5 hours to build the laptop. And then that means Cliff would take how long? 15 hours. Yep. I'm just going to prepare you guys right now. When I made the practice sheet for today, I did say you had to put every single answer in a sentence. I did say that, yes. Marvelous. Okay. All right, for the next part, what examples did I not do? So I skipped this, I didn't do this? Okay. All right. When you move, okay, so with or against problems are talking either about problems where you're moving with the wind or against the wind, or when you're moving with the current in water or against the current in water. Okay? So they're just talking about speeds with or without resistance. Does that make sense? We've all either experienced wind resistance or water resistance. Wind resistance, you just stick your head out the window of a car. Why did I say stick your head? Stick your arm out the window of a car? You guys are not dogs. All right, let's move on. Garth. Anyone have a friend named Garth? Marvelous. Garth can row 5 miles per hour in still water. It takes him as long to row 4 miles upstream as 16 miles downstream. How fast is the current? So if you move upstream, the current moves against you. This is a typo. When you move downstream, the current moves with you. So it's easier to go downstream because you're just floating along. It's harder to go upstream because you're fighting the current.
When we solve these problems like on a piece of paper, do we set up this box?
Mm-hmm. Because it kind of helps you. Huh?
It does help you
Yeah. Yeah. Like go through the problem. Okay. So we're always going to start by just kind of setting up this box, and this is kind of like the blank version of the box, and then we're going to write in everything. So, huh? Oh, you just were like, oh, it's blank? Yeah. So we did this first part? Yeah. Okay. So we need to do this example down here? No, we didn't. Okay, so we just need to do this back page? We need to do these two. Okay. Okay. Yeah, the first one was just supposed to be like, oh, this is the default version of the table that you're always going to fill in. So you're always going to have this when you get started. Okay. All right, so a plane flies 910 miles with the wind At the same time, it can go 660 miles against the wind. The speed of the plane in still air is 305 miles per hour. What is the speed of the wind? Okay, so
Asking what is the speed of it
Still.
with the wind, or what is the speed of it?
what is the speed of the wind, like if you're talking about like in still, so if you want to know the speed of the wind, then you're saying if the air was still, what is the wind like doing to influence the air? Yeah. So if we go back, we're going to say, if we're comparing it to the previous problem, the wind, x is going to be the speed in still air, c would be the speed of c would be the speed of the, I guess we could call it w, would be the speed of the wind.
Do we just memorize that for each? Like,
I would just keep referring back to this. So to be honest, and I'm going to teach you both of these problems because they both make sense for this unit. The previous ones, the ones that are rate of work, those are the ones that tend to show up on the EOC.
I've seen one of those on the EOS practice band.
Yeah. Those are the ones that tend to show up and get tested. These ones, I'm going to teach them to you because they are in the context of this unit. They're rational applications. Have I seen them on a test? No. Could they show up on my test? Yes. Are they fair for this unit? Yes. Are they showing up on EOCs? I haven't seen them. Okay. So that means it's good, like, put them on your cheat sheet, have reference information for them, or are you going to have to memorize it for the test at the end of the semester? Probably not. Yeah. Okay. So, all right. So for this particular problem, the rate is going to be 305 minus W if you're going against the wind, 305 plus W if you're going with the wind. So this is talking about the speed in still air. So you have the 305, that's your speed, and then you're adding the wind helping you along. Your speed, and then you're subtracting the wind pushing against you. It's going to slow you down. Does that make sense? Like common sense, kind of in working with your intuition there? Okay. All right, so what were the distances they gave us?
660 miles.
Okay, so 660 against the wind, and what about with the wind? 910. Okay. So what do I do to set up my fractions here? We go back. We have the time formula is time is, so if we look at this table,
Distance over rate.
so time is distance over rate. So we're going to do time is distance divided by rate. Okay, so time is distance divided by rate. Distance divided by rate. Distance divided by rate. Okay? So now I can say that these two ratios are going to equal each other because it says that these two things can happen in the same amount of time. That's why we're able to set those two fractions equal to each other. If they had different amounts of time, we wouldn't be able to set them equal. Does that make sense? Why we were able to do that in those previous examples? Okay, so 660 over 305 minus W equals 910 over 305 plus W. And then how do we not distribute yet? We're going to cross multiply, and then we're going to be distributing. Yeah. 660 times 305 plus W. 910, 305 minus W. Okay. We got some big numbers here, right? Whew. That was a sigh of contentment, right? Because you're enjoying this so much?
Yes.
Good answer. And then what should we do? Okay. And what else do we need to do? Okay.
Since there's two negatives, can't you take away both of them?
Mm-hmm. Mm-hmm. So we're going to divide by...
Negative 1. What did we divide by?
Yeah. So the wind is approximately 49 miles per hour. Okay, when you're done with that one, see if you can fill in the table for the next one. And notice the next one's different because they give you the speed of the current. And in some of the other problems, we were finding the speed of the current. So they're giving us something different. So you're going to have to look back at the previous examples because you're finding something different than before.
We're fine.
So normally we would have a C in the equation for the current, but we actually know what the current is this time, so we're not going to have a C in the equation. Yeah.
So, for example, the negative will cancel out as you need to divide by 1,470.
Mm-hmm. Okay, go ahead and check and see if you filled in your table correctly. Did we get it? Because the current is what they gave you, so the speed in still water is what we're solving for.
I mixed it around.
So you had to follow the order. We were finding the speed in still water, the x, so we had to follow this order. So it's the speed in still water, the current either slows it down or the current speeds it up. No, they're kind of showing you that these are just different variations of the distance formula. Yeah. Yep. Okay, so once you're done with this, once your table's good, go ahead and set up your equation. So we know that it says the same time. So since it says the same time, we can set these two equal to each other. And then go ahead and take a moment and try solving those.